we're going to take a look at the area of a sector of a circle. So if I'm given a circle and I want to find, say, the area of that circle, I can calculate that by taking area equals pi r squared, right? Well, if I only want the area of half of that circle, wouldn't I just take this? If I wanted half the area, then I would just take half of this, right? Or if I wanted just a quarter of that, so if I just wanted a quarter of that, then I would times that area by a quarter. So that means I would times this formula by a quarter. Well, what if I just wanted some sector of it, so some part of it? Well, so just some section maybe, so maybe just this section right here. Okay, well, I know that my angle is opening up so much, right? So I have some type of angle that this is open up to, that I want this area. But I know the full circle, my angle for a full circle is 2 pi, right? So the angle for a full circle would be 2 pi. And if I just wanted part of that, well, then I just want part of it. So I would just have to take whatever angle that I want, open up to be, divided by my full circle, right? That would give me a portion of it, right? If I have some kind of full and I want to, I have chocolate bar or whatever with so many slices and I only want to eat this one, that'd be 1 out of 1, 2, 3, 4, 5, 6, 1/6, right? Same thing here. If I just want a certain angle out of the full, then I would just take that angle divided by 2 pi. So then if I want the area of just this section opening up with my angle theta, then I would just multiply my area by theta over 2 pi. So that means I would take this formula and multiply that by theta over 2 pi. So then I'm taking area to find the area of a sector, and in the book it does like this fancy little a like that or something like that. That's the area of a sector of a circle. That's not that good looking a. Is theta over 2 pi times by pi r squared. Well, my pi's will cancel, and my theta is just my theta, and so I get theta over 2, which is the same thing as 1/2 of theta r squared. And so that's the area of, I think it's like fancy a like that or something like that. That's the area of a sector. So that's how I find my formula for area of a sector is 1/2 my theta times r squared. So if I know my r, then I can find my area of a sector if I know what my angle is going to open to. So I need 2 to the 3, right? So I need either these two to find this one, or I need this one and my angle in order to find my radius, or I need my area of a sector and my radius in order to find my angle. And so we'll go ahead and do an example like that real quick. Alright, so if I'm finding this area of this sector, okay, so I think it gives a description of irrigation or something like that. So you have this, and it's going all the way around in a circle, right, and coming back. But we only want to see how much the field might be just from, so we're watering this field, but our angle that we're doing is 15 degrees, and our radius from the center of the field out is 321, and we want to find the area of this sector. So we're going to take the area of a sector, something like fancy like that, is our angle and half of it. But again, this angle theta needs to be in radians. So I'm going to take this 15 degrees and multiply it by pi over 180. And so when I multiply that by pi over 180, that's going to cancel out here because that's like 30, so that's going to be 12. So I get pi over 12. So I'm going to take pi over 12 and I'm going to times it by 1/2. So that's pi 24ths. And then I'm going to multiply that by r squared. And here's my r is 321. 321 squared. So if I go ahead and do this out, I get the area of a sector, fancy something like that, is 1/2 pi 12ths times pi 12ths times 321 squared. And so I can take that on a calculator and I can go ahead and multiply it out, and I get something like approximately 13,500 meters squared. And so that's how you do area of a sector.